Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, I am going to discuss about one of the major energy sources which are useful in day-to-day life. That is all about the liquid fuels and the most common liquid fuel, petrol and diesel, and what are the refining procedures which we are following for this process. So it focuses mainly on liquid fuels, properties of the liquid fuels and the classification of liquid fuels and the composition of petroleum products and petroleum refining process in detail. So the all petroleum, including crude oil and products of petroleum refining, natural gas liquids, biofuel and liquids derived from hydrocarbon sources. So they are all the fossil fuels which buried and converted into these fossil fuels, the plant materials and the decay of the animal decay matter under high pressure and temperature, they converted into these are the pure hydrocarbon sources. They converted into these energy sources. So the petrol and the crude oil and natural gas liquids, biofuels and liquids all are derived from the natural source like fossil fuels, which are the hydrocarbon sources. These liquid fuels are combustible. This is nothing but it undergoes a combustion reaction. So it reacts with the oxygen and results in the combustible matter and heat or energy. Or energy generating molecules that can be combined to create some energy. Some sort of energy is released when it undergoes the combustion reaction or combustible process, usually producing the kinetic energy. So the fumes of these liquid fuels also are flammable instead of the fluid. Not only the fluid, the fumes emitted from this liquid are also flammable because the gas formed means the fumes formed from the liquid, they catches the fire and becomes flame. These are the liquid fuels. They are the important commercial as well as used as domestic fuels. Most of these fuels are obtained from the naturally occurring sources like petroleum or crude oil. So all these fuels are extracted from the mother of all these solution is the crude oil. So the properties. So these are the liquid fuels and what are the properties of such type of liquid fuels? So first and common most properties are density and viscosity. So the density is nothing but the ratio of the fuel's mass to its volume at a specific temperature like 15 degrees centigrade, and it is measured in kg per meter cube. Generally useful for determining the quality as well as the quantity of the fuel. And the next thing is viscosity. This is the measure of fuel's internal resistance to flow. So it gives the measure with the internal resistance to flow. So the most important characteristic is for this viscosity is generally measured to measure the storage and its use in different applications. This viscosity decreases as temperature increases. So if the temperature increases, it got concentrated and the viscosity decreases as temperature increases. Then another property is the flash point of the liquid. So lowest temperature at which a fuel can be heated so that the vapor gives off flashes when an open flame is passed over it. So at the lowest temperature, when this fuel is heated, the vapor gives off flame. The evaporated material or the gas or fumes, they catches the fire with an open flame. This is called as the flash point. The flash point of furnace oil is 66 degrees centigrade, and suppose because this furnace oil, when it was heated, the vapors emitted from this oil, open air flame will be here if it is a sample. It may be the furnace oil, petrol, or whatever it may be. We are going to measure the flash point of this particular liquid. So when it was heated with a source of heated with a burner, then what happens? The fumes will be emitted. Here open flame will be there. So the point at which this vapors catches the flame, they start burning. That point is called the flash point. So this point at 66 degrees centigrade, this furnace oil catches the fire. So this is the flash point of the furnace oil. Then coming to the petrol, it catches the fire at 43 degrees centigrade. In an open flame, the vapors are emitted from the petrol and it catches the fire at 43 degrees centigrade. So this is the flash point of the petrol. Then is the pour point. So this is the lowest temperature at which the fuel will flow. So at a minimum temperature, when this liquid fuels started to flow, this is the pour point. This is the indication of temperature at fuel can be pumped. This is the temperature indication at which point the fuel start flowing. This is called the pour point. This ranges from 32 degrees to minus 57 degrees, that is around 90 degree Fahrenheit to minus 70 degree Fahrenheit. It depends and it varies, depends on the chemical structure and the composition of the liquid fuels. So it may vary from 32 to minus 57 degree centigrade. So this is the pour point at minimum temperature, the lowest temperature at which the liquid, here this black line is the liquid flow. So at minimum temperature, when the liquid started to flow, this is called the pour point. So the another property is the calorific value. As we know, the higher the calorific value, the high is the demand and the high is the ranking for the fuels. So this heat and energy is produced is calculated in terms of the calorific value. So the gross calorific value generally GCV is vapor. Here the vapor is fully condensed, whereas the net calorific value NCV, the vapor is not fully condensed in this net calorific value. Based on this, we will give the calorific value of a specific or particular liquid fuels. And another feature and another property of the liquid fuels is the specific gravity. So the ratio of weight of oil volume to weight of some water volume. So the oil volume weight and the weight of some water volume, the ratio between these between to oil and water at a given temperature, this is called the specific gravity of water, specific gravity of liquids. Generally, the specific gravity of water is 1 and hydrometer is generally used to measure the specific gravity in different liquids. And another content which is a like contaminant is sulfur. It depends upon the source of crude oil and less on the refining process. Generally, crude oil is obtained from the earth, and we don't know and we can't predict the composition between where the crude oil interacted with the other elements present in the earth surface. Suppose this is the crude oil flow. The surrounding rocks may be the sulfur rocks, some coal rocks. So we cannot predict because the way and the source of this crude oil also plays a role in the presence of this sulfur or other minerals or other rare earth elements or anthracite rocks. So it depends upon the source of the crude oil. So it depends on and one of the content like sulfur content is also purely depends on the source, not on the refining process. It won't add during the refining process much. Generally, the furnace oil will have 2 to 4% of sulfur. Sulfuric acid causes corrosion. So the sulfur present in this crude oil reacts with the hydroxyl molecules and forms the sulfuric acid. So this sulfuric acid generally causes the corrosion of the refining process. In general, For the refining of the petroleum or the liquid fuels, these refining units will be there. They are made up of steel, and due to the high temperature, it undergoes a process of reactions. During this process, we will use the big tanks, cylindrical tanks. So, if the sulfuric acid is formed in the crude oil or in the refined products, it causes the corrosion. So, this is like a contaminant. The ash content is the inorganic material present in the fuel. It is typically 0.3 to 0.77% present in the liquid fuels. The corrosion of burner tips and damage to the materials or equipment at high temperature generally happens due to the presence of the ash content. If the more ash content is present in the liquid fuels, it damages the equipment and the materials which is used in the corrosion, the burner tips. So it causes the corrosion and specifically at the tips of the burner due to the high content of the ash in the liquid fuels. So the specific heat. This is measured generally in kilocalories. It is needed to rise temperature of 1 kg oil by 1 degree centigrade. This is kilocalorie per kg at specific degree centigrade. So it is needed to raise the temperature of the oil by 1 kg oil by 1 degree centigrade. This is called the specific heat. It indicates how much steam or electricity takes to heat the oil at a desired temperature. So this is the major thing because it indicates it's going to give the temperature at which the steam or electricity we needed to raise the temperature of this crude oil specifically to heat that oil at like 1 kg oil at 1 degree centigrade temperature. This is the specific heat of the liquid fuels. There is the carbon residue. So the tendency of oil to deposit a carbonaceous solid residue on a hot surface. So this is residual oil will generally have 1% carbon residue in their composition on the water content. The normally low in furnace oil supplied, generally the furnace oil they generally will have low content of water and free or emulsified form, so can damage furnace surface and impact the flame. So the presence of this emulsified and free foam gives the furnace surface got damaged because of the high water content, because the water also plays a vital role in the corrosion formation. So it should be water free and the low content of the water should be generally preferred in this furnace and crude oils generally in the refining process of these liquid fuels. The storage. Coming to the storage, based on the specific gravity of the particular liquid, the storage tanks will be decided. How much suppose in a cylindrical tank, how much kilocalories or how many kilograms or kgs of oil can be stored. So this generally happen in cylindrical tanks above or below the ground. It may be the underground or above the ground. So the storage tanks, cylindrical tanks are generally used in the preservation of these liquid fuels, and 10 days more than recommended storage is more than 10 days for normal consumption, and these tanks should be normally or cleaning should be done at a regular intervals. So the next is the classification of the liquid fuels. So the liquid supply generally divided into oil supply, the oil production, refinery processing grains, then it again divided into the conventional and unconventional oil types. Then this conventional oil category, this is what we are focusing today. This is crude oil and natural gas liquids. So this is NGs. So natural gas liquids comes under this conventional oil category. So in this crude oil, like other crude and condensate will be formed. In this natural gas liquids, the condensate, ethane, propane, butane and pentane, these gases are formed from the natural gas sources. So coming to the oil supply, next the biofuel supplies. So the biofuels are ethanol, biodiesel and other biofuels. So whereas in the oil production, two types like conventional and unconventional oils, the unconventional oil like extra heavy oil and bitumen formation, and tight oils like gas to liquids, coal to liquids and kerosene oil formation and the additives. So come to the extra heavy oil and bitumen. The oil sands and extra heavy oil comes under the extra heavy oil category of the bitumen. So this is the petroleum refineries. So it undergoes, the crude oil undergoes a process and a stages of refining process. So the whole system and the whole equipment will be like this. So this is the cylindrical tank. So they have some fractions. So from the each fraction, they based on the temperature, it releases some oil that we are going to see the process in the process of refining of petroleum. So what are the examples of these liquid fuels? So the best and the foremost useful liquid fuel is the petroleum. So this is the single largest source of liquid fuel. It is called the petroleum. This petroleum means, petra means rock and oleum means oil. So it is nothing but the rock oil. So rock oil or mineral oil. Petroleum is the rock oil or mineral oil. So the crude oil, petroleum, is generally a viscous liquid. It is very thick liquid which is having the high viscosity nature, containing hydrocarbons. As we know, all these energy sources are derived from the fossil fuels. That fossil fuels are the hydrocarbon atoms. So all these fossil fuels are the crude oils or liquid gases. They contain only hydrocarbons. So only carbon atoms and hydrogen atoms in some traces of other elements. So the main backbone chain is hydrocarbons. Petroleum also contains small amounts of non-hydrocarbon mineral impurities that we extract from underground deposit at a depth of 500 to 1500 feet at various places. So first they identify the sites of crude oil extraction. What happens? So this is the earth surface. They identify the locations to dig and to extract the petrol refineries or crude oil extraction. So with the detectors, once they got the site on the surface, they will go up to 500 to 1500 feet of depth into the earth's surface. So 1500 feet, what happens? The anaerobic decay and kerosene formation, the transformation of kerosene into the fossil fuels. The fossil fuels, see here, this is the earth surface. This is around 1500 feet. Here gas and petroleum. So they will extract both this. This is the natural gas and this is the petroleum, which is discussing today. One of the largest source of liquid fuels is petroleum. So as we know, this is a thick viscous liquid. The crude oil which we generally extract from the earth's surface is not like as the petrol we are seeing in the market. It is a thick liquid viscous liquid which may be in a black or dark brown, but also can be yellowish, reddish, tan or even greenish. It depends on the source of the rocks present or the source of the contact present between this crude oil and the rocks. The color may varies, like it may be dark brown, black, yellowish, reddish, tan or even greenish. The variation in color indicate the distinct chemical compositions of different supplies of crude oil. So if the content or the chemical composition varies, the color definitely varies. So the presence of these colors is due to the chemical composition or the interaction with the crude oil with other rocks. Petroleum that have few metals or sulfur, for instance, tends to be lighter. If it is having less amount of sulfur and fewer metals, then the color of the crude oil will be very light. The crude oil is a source of many liquid fuels that are in current use. It is a source of all the fuels. So the composition of crude petroleum approximately means, as we know, the petroleum is nothing but the major content is hydrocarbon. So what are the composition of the crude petroleum? So without any extraction process, if we take crude petroleum, then the carbon percentage is 80 to 85% and hydrogen is 10 to 14%. So this is hydrocarbon. the traces of hydrocarbons, and we also know non-hydrocarbonous material, which is nothing but the sulfur and nitrogen. The traces are 0.1 to 3.5%. Suppose for 100%, so for 100 grams of petroleum, it is around 3.5 gram is sulfur and 0.1 to 0.5 gram is nitrogen. And 80 to 85 gram is carbon, 10 to 14 gram is hydrogen. So as we know here itself, the most of the major constituent is hydrocarbon. Even very less amounts of sulfur and nitrogen also causes like corrosion due to the formation of sulfuric acid. So this is the process of this is the composition of crude petroleum. So this undergoes a process of at different stages to get it pure and to make it useful for the automobile industry. So this is the crude oils. Again, it divided into different types based on the hydrocarbons and non-hydrocarbons. So again, hydrocarbons based on the structural arrangement or the cyclic arrangement. Again, it is divided into aliphatic hydrocarbons, aromatic hydrocarbons, and naphthalene. Whereas in non-hydrocarbons, it was divided into sulfur, nitrogens, oxygens, and metallics. So the sulfur present also should be less than 8%, whereas the nitrogen percentage should be less than 1%, whereas oxygen it should be less than the 3%, and metallics should be less than, it is not the percent, this is parts per million. So 1 million parts per million, it should be less than 100 parts per million part of the liquid fuels. So what is refining? As we know the crude petroleum composition and what are the types and what are the hydrocarbons and non-hydrocarbon materials present in the crude oil. So this impurities presence causes a problem because we cannot use directly in the industry, and we cannot the applications of the petrol cannot be fulfilled because of the presence of all these impurities. So it should undergo the purification process. The purification process is nothing but the refining process. So the process of purification and separation of various fractions present in the petroleum or crude oil by fractional distillation is called the refining of petroleum. So it undergoes a separation process. So by the fractional distillation, this is one of the process. So the process is called the purification or refining of petroleum. So the refineries are complex, capital intensive, lot of amount has to be spent, and manufacturing facilities that convert crude oil into a variety of valuable products. So the crude oil we got will be very high viscous liquid that should be purified and it undergoes a stages of process to get it pure. So the refining process uses chemistry to break, reshape and recombine the molecules of crude oil into value-added products like gasoline, diesel and aviation fuel. Aviation fuel is nothing but the fuel which is used by the air vehicles, means like aeroplanes, helicopters, even in all these uses this aviation fuel. Like road vehicles, that air vehicles need to have this aviation fuel. So this is the refinery. So the first crude oil which we get from the earth undergo the desalting process, then the distillation, then the downstream processing, then the purification. So at the point of desalting, removal of corrosive salts, like the salts present in the crude oil, so and the suspended soils removed at the process of this desalting process. Whereas coming to, so once the removal of corrosive salts and suspended salts are removed, it enters into the distillation process, where the separation into major distillation fractions. So the separation happens into the major fractions. Then the change of molecular structure of hydrocarbon molecules happens in the downstream processing, and some emissions of like gases like hydrogen sulfide is emitted in this process. Again, this will go to the refinery wastewater. So from the desalting water which is removed also goes into the refinery wastewater. So once this process happens, again it goes here. So after the completion of this process also it goes here, and this is the refinery wastewater. So once the change in the molecular of hydrocarbon molecules, it undergoes the purification such as denitrogenation, desulfurization and demetallization, where the purified compounds got denitrogenation because the nitrogen present in the crude oil is removed, sulfur present in the crude oil is removed, and the metallic compounds, unwanted metallic compounds present in the crude oil are removed in the process of purification. So once this process completed, then the petrol is ready to have to use in the automobile industry. Not only the petrol, the gasoline, diesel and aviation fuel. So from the crude oil is the mother of all these oils. So from this the extraction process goes on. So it differs, the hydrocarbon chain differs from diesel to petrol and gasoline or aviation fuel, it differs. So based on the requirement and based on this hydrocarbon, we will separate, and all the separated compounds has to undergo again denitrogenation and desulfurization and demetallation to remove all the unwanted metals, nitrogen and sulfurs present in the petrol liquid fuels. So as it is a complex process, so this is the steps which is going to happen in the liquid petroleum refinery. So this is the crude oil. So it goes through the pump. Here this is the fractional distillation. As we know, this is the desalter where all the suspended solids are removed here. Then it enters into this is the burners. So again from this it enters into the fractional distillation where the major fractions are divided, and here the steam first gives the jet fuel, light gas oil, heavy gas oil and the residue of the fuel oil. So after this process it undergoes again. So this is like condensation process. The fumes are collected in the fractional distillation. Once collected, they are cooled down and converted into the liquids through the pumps. So this is nothing but, the gas is nothing but the steam. So this is the petroleum refining. So here this is the boiler and this is the source, crude oil source. So it undergoes the boiler, then distillation column where the temperature we can see is 600 degrees, 300 degrees, 200 degrees, 120 degrees, 70, 40 and 20 degrees. So based on the boiling this is based on the temperature, the evaporation rate. The first 600 degrees is the coker. This is called a residue crude oil. So it contains 80% of the carbons, and heavy gas oil, it is at 600 degrees centigrade. In around 400 degrees, 600 to 300 degrees, that is around 400, lubricating oils. It have 36 carbon atoms, and here in between 200 to 300 degrees centigrade, suppose it is like here gas or diesel oil which contains 60 carbon atoms. Then this is the alkylation unit where we will get the kerosene which contains 12. Then at 130 degrees centigrade we will get the gasoline with 8 number of carbon atoms. At 40 degrees centigrade this is the reformer, and naphtha we are going to get with 8 carbon atoms, and at 20 degrees centigrade finally we are getting is the gas which is 4 carbons. So the refining of petroleum, as we know, this is the process going to happen. So we are going to see in detail from step to step in this refining process. First is the removal of solid impurities. The crude oil is a mixture of solid, liquid and gases. And all these the crude oil contains all these molecules like solid molecules, liquid and gaseous molecules. So this is allowed to stand undisturbed for certain period of time. So when the heavy solid particles settle down and gases evaporated, what happens? It was allowed to stand at a particular time without means we should not disturb. So without undisturbed, the heavy particles settle down at the bottom and the gas present in the petrol or less crude oil, it evaporates. So here the oil slurry, so if it is a crude oil, it is kept undisturbed. So the gases present will evaporate. So we are removing the gases here, and the heavy molecules or heavy substances or heavy molecular weight compounds settle at the bottom. So this can be filtered. So we are removing most of the solid content which is settled down at the crude oil bottom. So the supernatant liquid is then centrifuged wherein the solids get removed. So this undergoes a process called centrifuge, where the centrifuge is nothing but the solution was rotated at a specific RPM, rotations per minute. It may be 10,000 or 12,000 or 20,000. So it was rotated. Due to this force, the solid particles or the heavy compounds or solid get precipitated or settled down at the bottom of this crude oil. So by this process, this filtration can be done. So here most of the liquids and most of the gases and solid forms are removed in this solid impurity removal step. Then it undergo the process called Cottrell's process, which is the removal of water. So the crude oil obtained from the Earth's crust is in the form of a stable emulsion of oil and brine. So it also, because by the collection from the Earth, it is at the time of collection from the Earth's surface into the deeper layers of Earth, it is an emulsion. Because means it contains oil globules and water molecules. So it is oil and brine is the sodium chloride, some sodium salts of solution, water. This mixture, when passed between two highly charged electrodes, will destroy the emulsion films. Emulsion is nothing but the oil globule formation. If we add oil into the water, the globules will form. Suppose this is the water. If oil is added, we can observe the globes formation, some molecule formation with the oil. This is the emulsion. This can be removed by passing this water between the two highly charged electrodes, will destroy these emulsion films, and the colloidal water droplets fall into bigger drops and get separated from the oil. So this is passed, these are the high voltage electrodes. When crude oil is passed between these two electrodes, this is also electrode. So between these two electrodes, this is the water molecule or emulsion molecule. What happens when crude oil enters into these two electrodes? This got damaged, the emulsion got damaged, and it gets separated out from the oil. Then the removal of harmful impurities. In order to remove the sulfur content in the crude oil, it is treated with copper oxide. What happens is copper oxide reacts with the sulfur and results in the formation of copper sulfate plus oil. Copper sulfate plus oil. The sulfur compounds, as we know, the sulfur content in the crude oils also causes the change in the color of the crude oils. Though the sulfur is also mostly unwanted material. As it reacts with the hydrogen and oxygen atoms, results in the formation of sulfuric acid, which is a highly corrosive compound. So the removal of sulfur is important in this process. This can be done with the copper oxide. So the copper oxide is mixed with the crude oil, then copper sulfide formed will removed and oil is obtained. So some substances like sodium chloride and magnesium chloride, it present, will corrode the refining equipment, result in scale formation in the refineries. So this can be removed by techniques like electrical desalting and dehydration process. So here the impurities sodium chloride, magnesium chloride and sulfur can be removed by these techniques. So the next step is desalting process, where most of the materials like suspended solids are removed in this step. So it consists of three main stages. One is heating, mixing and settling. So the crude oil is first undergoes a heating process at 135 to 141 degrees centigrade in a train of heat exchanger operating in two parallel sections. The temperature of desalting is maintained by operating a bypass valve of a heat exchanger. This single stage desalting with water cycle is usually justified if salt content. So it depends. So whether we have to go for the single stage or it's a continuous exchanger process, it depends upon the salt content present in the crude oil. If it is less than 40 ppb, we can use the single stage. The double stage desalting is better for residue hydrotesting and by injecting water, the salts dissolved in the water and solution are separated. This is the desalter. So this the desalted crude oil is coming from here. So the crude oil tanks undergo a chain of reactions like preheated train exchangers will be there. Here in the desalter, due to the mixing and the continuous heating, mixing and settling process, it use of the brine solution, and the salt is removed. Most of the salts are removed in this desalter, and the oil obtained from this process is called the desalted crude oil. So the fractional distillation. So what is fractional distillation? So the most of the impurities removed like sulfur, magnesium chloride, sodium chloride, and it undergone desalter. Then it moved on to the fractional distillation, where the different temperatures were used. This is generally the process of the fractional distillation. So heating of crude oil around 400 degrees in an iron retort produces a hot vapor, which is allowed. So here the first what they will do, they will heat the crude oil at 400 degrees centigrade. So it starts giving the vapors. Once the vapors came, they are allowed to pass through this fractional distillation process. So it is a tall cylindrical tower. We can see here the tall cylindrical tower over here containing a number of horizontal stainless trays at short distances, and is provided with small chimney covered with loose cap. So the chimneys are provided with loose cap. It absorbs the vapors. As the vapors go up, they get cooled gradually and fractional condensation takes place. So from here to here, the temperature decreases. So around 400, it will decrease to around 20 degrees centigrade. So as the fumes goes on, the temperature comes down and it gets cooled gradually. So the higher boiling fraction condenses first, and the lower boiling fractions are next. So the higher boiling fraction first condenses easily, and the crude oils which is having the lower boiling fraction will be eluted at last. So this is the pictorial representation of refining petroleum. As we know, here we have seen the process of how it enters into this stainless streams. So here the first is lubricant. Here the higher fractions like lubricant oil will have more carbon atoms, then diesel, kerosene, naphtha, gasoline and petroleum ether. So depending upon their boiling temperature, as we know, this is petrol will enter here and it was heated to 40 degrees. So when it starts giving the vapor or fumes, it enters the fractional distillation here. So again, based on the heavy oil, lubricant oil, all these different fractions of liquid fuels are eluted here. So the different compounds that are separated out during the process, that are called fractions. So these are separated out including like gasoline, petroleum ether, naphtha, kerosene, bitumen, diesel, lubricant oils. So these fractions allows a lot of usable products can be, due to the fractional distillation, a lot of useful products can be made from crude oil with many environmental consequences. They have the vital role, and these are the useful products. And this is the general representation to know how this petroleum fractionation are. This is the fractional distillation. This is the boiler with 400 degrees centigrade. This is the crude oil. So the vapor entered into the fractional distillation. We can see the horizontal stainless levels where this is at lower temperature, like gas fuel, like liquid petroleum gas, crude petroleum, then petroleum ether, naphtha fuel was obtained here, followed by kerosene, next diesel, next this lubricant oils. So here heavy oil and lubricant oils. So this is the way of fractional distillation happening. These levels are called fractions. So we know these all products are formed from this fractional distillation. So what are the boiling range of petroleum gas? It is less than 30 and the carbon composition is C1 to C4. This change into liquid under pressure. This petroleum gas which is obtained from the fractional distillation can be changed into liquid under a particular pressure, and generally used cylinders are filled with the LPG gas. This is the household fuel which we are using for cooking purposes in all the homes is LPG gas. This petroleum gas obtained from this process is converted into this LPG. LPG is liquefied petroleum gas. So the petroleum gas which is obtained will be converted into liquid. That's why the name liquefied petroleum gas. Then is the petroleum ether, which has the boiling point range of 30 to 70 and the carbon composition is C5 to C1. It is used as a solvent in all the R&D institutes and it is applicable in some lubricants and all. They use it as a solvent. Then gasoline or petroleum, which is having 40 to 120 degrees of boiling temperature and the composition is C5 to C9 as a solvent and in dry cleaning. And the naphtha 120 to 180, it is C9 to C10. It is used as the paints, varnishes and dry cleaning purposes. This naphtha is used. Kerosene, it is 180 to 250 degrees centigrade and C10 to C16 is the composition. It is used as a household fuel in pressure stoves and petromax lamps and it is also used as a solvent in many industries. Coming to the diesel oil, which is having the high boiling point. It is around 250 to 320 degrees centigrade and C10 to C19 is the composition as it is used as an engine fuel in the automobile industry. Coming to the last fraction, that is heavy oil, it is having a high boiling point of 320 to 400 degrees centigrade. So the carbon composition is C17 to C30, used for getting high quality petrol by the process called cracking. So what are the advantages of, as we are getting so many liquids or so many fractions from this column. So what are the advantages? So they have high calorific value per unit mass. They burn without ash. As we know, the solid fuels like coal, anthracite, bitumen all gives ash content. So the disposal causes a main headache for using as the fuels. Compared to the solids, these liquid pet fuels won't give the ash or clinkers, etc. So the controlling the combustion is easier compared to the solid fuels. The transportation easier through pipes and stored indefinitely without any loss. The loss of energy is comparatively low and requires less furnace space for the combustion process. What causes the disadvantages? The fractional distillation process involves a lot of techniques and lot of equipment. So it gives the higher cost compared to the solid fuel. So the cost is bit high compared to the solids and storage methods also costlier. As it becomes a vapor at a particular temperature, it should be preserved in a designed equipment. So that causes one of the disadvantages. And fire hazard, it catches the fire easily because the vapors getting from the liquid fuels are also able to catch the fire. Other than liquids, the gases or the fumes evolved from the liquid fuel are able to catch the fire. So the fire hazard will be a greater risk. And for special burning equipment is required for the process and for the most efficient combustion process. A special requirement of equipment also needed. So these are the disadvantages of the liquid fuels. So this is all about the petrol process of refining and the liquid fuels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.